An introduction to indices. Two to the power of 3. The 2 is the base, the 3 is the power or the index. Some basic rules of indices. If the base is the same and you're multiplying terms, you can add the indices or the powers. So for instance, 3 to the power of 2 times 3 to the power of 4, we're multiplying. The bases are both 3, so applying this rule we can add the powers to give 3 to the power of 6. We're multiplying 3 terms together here. The bases are all the same, they're all equal to y, so we can add the powers. So 4 plus minus 3 plus, there's no power here. If there's no power, then 1 is implied in there. So plus 1, which is equal to y to the power of 2, or y squared. In this example, again, we're multiplying. The bases are both 2, so the bases are the same. So we can add the powers. So the x and the 1 minus 2x, we can add them together. So 2 to the power of x plus this, 1 minus 2x, which is equal to 2 to the power of, and the brackets aren't really doing much here. So x minus the 2x gives you minus x, and then you've got a plus 1 there. So you've got 2 to the power of 1 minus x. And in this last example, the bases are both 3, but there's a problem. We're adding these terms, we're not multiplying, so there's nothing you can do here. So if you were thinking that you could do something like this, 3 to the power of a plus 2a, that's wrong. You can't add the indices, you're not multiplying the terms, so this rule here does not apply to this. When dividing terms, and the bases again are the same, we subtract the indices or the powers. So x to the power of 5 divided by x to the power of 2, the base is x in both of these, so we can subtract the powers, the top one minus the bottom one, which gives x cubed. Again, we're dividing, the bases are the same, so we can subtract the indices. So a to the power of x minus, so this power minus this one, and you have to put this in brackets, otherwise you'll get the signs wrong, like this. So that's a to the power of, and if I take the brackets out, that's minus 1, and minus 5x will give you plus 5x, and simplifying this will give you a to the power of, so you've got x plus a 5x, that's a 6x there, minus 1. The power on power rule for indices, so we've got something inside the brackets with a power, then everything in the brackets is raised to another power. So these two powers here are multiplied together. So in this example, 2 to the power of 3, and all of this to the power of 4, using the power on power rule, we're going to multiply the powers together here. So 3 times 4 is 12, that's 2 to the power of 12. In this example we have 2x squared, all of this to the power of 4. So this power of 4 will go on the 2, and the x squared. So we have 2 to the power of 4 times the x squared to the power of 4, which is equal to, now 2 to the power of 4 2, 4, 8, 16. Applying the power on power rule here, 2 times 4 is 8. So 16 times x to the power of 8. This is in surd form, so we have root x, and root x is just x to the power of a half. So this is the part inside the brackets, and then it's all to the power of 3. So removing the brackets, so multiply the powers together, and a whole number times a fraction. The whole number only multiplies with the numerator. So I've got x to the power of 3 over 2. In this example, I'm going to show how you can swap these powers around. Because you just multiply them together, you can switch them around like this. And sometimes this can be very useful. So 2 to the power of 4 is 16. So I can write the whole thing as 16 to the power of x if I want to. Okay, so what happens if the power is equal to 0, or the index is equal to 0? For example, this. A to the power of 0. Anything to the power of 0 is always 1. So here we have 4x squared in brackets, so everything inside the brackets is raised to the power of 0, which gives you 1. One to the power of anything is always 1. So for instance, 1 to the power of 14 is equal to 1, and 1 to the power of x is equal to 1, because 1 to the power of anything is always 1. Changing the base to simplify. To simplify this fraction, if I identify that 49 is actually 7 squared, so I can write the 49 as 7 squared, that's the 49. Squared over 7 to the power of 3. Applying the power on power rule here, 2 times 2 is 4, so 7 to the power of 4 over 7 to the power of 3. And because we're dividing, the base is 7 in both of these, so I can subtract these powers, which just gives 7 to the power of 1, and anything to the power of 1 is itself, that will just give 7. In this, if we identify that 64 is actually 8 squared, so if I write 64 as 8 squared, and that's 64 to the power of 5, so this will be 8 squared to the power of 5, divided by 8 to the power of 5, applying the power on power rule here, 2 times 5 is 10, over 8 to the power of 5, and then we subtract the indices because we're dividing and the bases are the same, so we have 8 to the power of 5. 2 to the power of 3 over 16 squared. In this one, if we focus on the denominator, so the denominator and the base there is 16, now 16 is also a power of 2. So 16 is 2 to the power of 4. That's just the base. So the 16 here, ignore the 2 there, just the 16 is the same as 2 to the power of 4. Now this 16 is to the power of 2, so this 2 to the power of 4 must also be to the same power, to the power of 2. So then simplifying, 4 times 2 is 8, 2 to the power of 8, and then subtracting the powers, so that gives 2 to the power of 3 minus 8, which is minus 5. And 2 to the power of minus 5, if you want to, you can rewrite it in a different way, but in some questions they say simplify this, so starting with this fraction here, simplify it, giving your final answer as 2 to the power of n, which we've achieved here. But if that wasn't stipulated in the question, then I might be tempted to take this a bit further, because 2 to the power of minus 5 is the same as 1 over 2 to the power of plus 5, and this part here, 2 to the power of 5 here, is the same as 32, so we get 1 over 32. In this question, we have a number of different bases. These are all different, and it would be sensible to use a base of 2, the smallest one, to represent all of these terms. So 8 is 2 cubed. It's 8 squared. So I've got this. This is already to a base of 2. Denominator now 4 is the same as 2 squared. 4 to the power of 5, 2 squared to the power of 5. And now we're just simplifying. So 3 times 2 is 6. 2 to the power of 6 times 2 to the power of 4 over 2 times 5 is 10. 2 to the power of 10. Adding the indices, 6 plus 4 is 10, divided by 2 to the power of 10. Anything divided by itself is 1. Another way of thinking of this is, because we're dividing, I can subtract the indices. That gives 2 to the power of 0. Anything to the power of 0 is 1.